Good afternoon, everyone. Myself, Sindhini Minister from CSC third year. So, for the experiment number 4, we are going to see the working and implementation of single layer perceptron, where the aim of the experiment is to develop a single layer perceptron classification model and to evaluate the performance of the model. So, what is meant by single layer perceptron? It is a type of artificial network which works on the features of input and weighted sum and a activation function. So, we'll be looking how the artificial neural network of the single layer perceptron will be working. So, coming to the experiment, first we are going to import all the libraries which are pandas, numpy, and matplotlib for the visualization of data points. So using scikit-learn, we are going to input machine learning algorithms, which are nothing but label encoder standard scalar. They are all types of preprocessing techniques used in the process of data preprocessing. And to split and train the data, we are going to use model selection inside scikit-learn library, and then import the measuring techniques, which are accuracy score, precision score, recall score, FI score, confusion matrix, and classification report for checking in the process of checking of the algorithm working. So first we are going to import the data set, which is given penguins for the single layer perceptron, and this is a data set. Now we are going to check the statistical measure of mean for the given data set. So as we can see here using fill now we are going to handle the missing values in the given data set of SLP penguins. So here we are going to check the in process of handling the missing values, we are going to take the statistical measure of mean and then going to place and handle those missing values and in place the mean of the given data set. Here we are going to take the dependent and independent variables, which species are dependent variable and which is also known as target variable. And using label encoder, we are going to fit the transform of this dependent and independent variables. And here we are going to create a new column df species where we are going to fit and transform this df species, which is target variable. So we are going to declare the x and y variables where x are independent variables and y are dependent variables. In the next step, we are going to standardize the given input features. Here, I'm going to standardize the input features so that all the variables are on the same scale. This is important because features like body mass and bill length may have different ranges, and standardization helps the perceptron to learn more effectively. So, using standard scalar, we are going to standardize the input features, and in the next step, we are going to split the data into training set and testing set. So in this step, I divide dataset into training data and then testing data. The training data is used to train the perceptron model, while the testing data is used to evaluate how well the model performance is observed on unseen data, which is also known as generalization. Generalization helps us to see how good a model works well on an unseen data. So next, we are going to initialize the model parameters were required for training the single layer perceptron. These include in learning data and the number of iterations, the initial weights of each features and the bias value. Here we have given that iterations of 100 and the learning rate, which is nothing but eta, is 0.01. Once we get input features in artificial neural network, each input features is weighted to a weighted sum, and the whole weighted sum is being calculated and checked for the target variable prediction. So here, after I initialize, we are going to calculate and update the weights after during each iteration. As iterations are given 100 and learning rate is 0.01, for 100 iterations is going to check the weighted sum of the each input feature in the process of calculating it. In this step, the perceptive training process begins. For each iteration, the model calculates the predicted output, and then it compares it with the actual output, which computes the error and updates the weights accordingly with the bias using the perceptron learning model, which is nothing but SLP. And then we are going to display the final weight of each input attribute of the training. After completing all the training iterations, we are going to display the final weights for each input feature. These weights represent the importance of each feature in the classification process. In the for loop, we have initialized the weight, which is the variable which we have taken from this. We are going to check through the each weight, and then concurrently we are going to update the weights. So here we can see that the weight 1 is this weight 2, weight 3 with the bias of 0.01. Next, here we are going to plot a graph which shows the relationship between the number of iterations and the error during the training. This helps us to visualize the model, how efficiently it learns and decreases the error over time. We have plotted a graph between the iteration versus error using matplotlib library, which is plot, and over the iterations the errors is going to plot, where x label is iterations and the y label take out the error column and then the plotting. Next, we are going to predict the class labels. By derived overall training and testing of this data on artificial neural network and updating the weights and using an activation function. In this step, we use the trained perceptron model to predict the class labels for the next test data. Finally, we are going to evaluate the model performance by generating the confusion matrix. So y predict is equals to predict x test, which is nothing but after testing the x split data, as we have split the data here, x y x test x test. So the tested data is being used in order to predict the target variable. So here we are going to take y predict and then going to predict the x test from the tested data, and then in order to build this confusion matrix we need the y test and y predict, which are taken from this loop. So confusion matrix is built where uh, This, mat- this matrix helps us to understand how well the model performed in the process of calculation. In measuring the metrics such as F1 score, mean squared error, and so on. So here we can check how accurate our model of single layer perceptron has been trained and well gave new outputs on well unseen data. So accuracy, precision, recall, F1 score are some of the metrics used in the process of classification. And this will be the overall classification report of the model trained. So, giving an inference, the single-layer perceptron model was implemented and trained after processing the dataset. The model predicted the test and data, and its performance was evaluated using a confusion matrix, accuracy, precision, recall, and F1 score, which shows effective classification of the data set. Thank you.